I'm really excited to be here, and I really appreciate it. So my talk today was originally titled as this: the continuous profiling provides short path for performance tuning. But the title was too long for the agenda table on the website, and then it was shortened to continuous profiling dot dot dot. After looking at this, I thought the original title was too long, and the title should be into the point. So I changed it to the continuous pprof. This title describes the talk content more. Though the title is specifically calling out pprof, the technique can be applied to other profilers tools. One thing to note here is that though this conference is mainly focused on the OpenTelemetry, my session is about profiler, especially pprof, because it is key supplement for OpenTelemetry. Before getting into my presentation, let me introduce myself a bit. I'm Yoshi Yamaguchi. I'm a developer advocate in Google Cloud based in Tokyo office. So now it's 11:30 p.m. here. It's great to see a lot of people are joining this event from all over the world. Anyway, my technical focus is primarily on the observability, product-wise, Google Cloud Operations, formerly known as Stackdriver, and also OpenTelemetry and OpenCensus. Another focus is on DevOps/SRE, especially on build system. Recently, I'm focusing on Bazel as well. And lastly, Go programming language is also my focus. I've been running Go Conference Tokyo since 2013. So if anyone is interested in joining the event, let me know at the speakers channel. So today's slide is published via this URL. So you can review any slide at any time you want after the session. So you don't need to take screenshot or take photos of the slides during the session. Okay, so let's move on to the main talk content. So when we talk about observability, we often mention 3 pillars of observability. Each of them are logs, metric, distributed trace. This is also mentioned in FAQ section in OpenTelemetry offshore website. In Google Cloud Platform, we have cloud logging, cloud monitoring, cloud trace, respectively. As you know, metrics and distributed trace are already covered by OpenTelemetry, and log is under discussion for its spec among logs SIG. So OpenTelemetry may support all of those components in the future, hopefully. This is awesome. In order to think about the difference among these observability components, let me start from the tech stack coverage. The boxes on the left side are the layers of the system. There should be different ways to describe it, but I use them just for the ease of explanation. Distributed trace basically look at the application layer or the service layer in microservice. It gives the idea of the function level latency bottleneck. Logs and the metrics covers layer above OS because a lot of middleware and OS emits logs and metrics out of the box. And in the context of the application performance management, we instrument logs and metrics in application codes. In terms of tech stack coverage, the profiler covers the layer, it covers the same layers as the logs and the metrics. Then what kind of use cases only fits to the profiler? The trace and logs are basically event-based, whereas metrics and profile are sampling-based. From this point of view, logs are different from profile. Then what's the difference between the metrics and profiles? So let me explain the difference between matrix and a profile by these pictures. In matrix, we embed the instrumentation to collect the data in each functions or method in the application. In general, we have the instrumentation for different metrics in each functions and methods. The timing of sampling is a moment, and the collector of metrics records the value of the specific timing. On the other hand, in profile, the instrumentation is only done in main function. And usually, it launches the agent to take the metrics at the profile initialization phase, and that's it. The metrics to take is predefined, and the same across the stack trace, such as CPU usage, the heap size, allocation count, and so on. The sampling period is longer than metrics, like 10 seconds. And it is by default single shot sampling. It takes the value of target metrics within a certain period across the stack trace. Because the way of instrumentation and sampling are different, the expression of the result is different between the metrics and the profiles. In metrics, metrics are typically expressed as the time series data in line chart format. And each metrics has its own chart. One thing to note here is we can put multiple lines in a chart for the same metrics with different labels. For example, we can put the CPU usage of multiple VM instances in single chart. In profile, what we get is a single graph or list that is transformed from the statistic data, such as directed graph, flame graph, top, and so on. So this is the summary of the difference between metrics and the profile. In metric, we pick arbitrary measurements that describes the status of application or system. In profile, we have predefined measurements such as CPU usage, heap size, number of native threads. Those are related to the performance of the application. In terms of sampling, metrics takes the continuous, periodical, and instant sampling, whereas profile takes longer single shot sampling. Because of way of sampling, metrics expresses the data in time series manner, while profile expresses it in a statistic way. Especially profile gives the context of stack trace to obtain the results. This helps us to understand the bottleneck inside the application, and that is what metrics is hard to give. So the reason why we need profiler is because profiler helps you to identify the root cause of the issue with the context of the stack trace at a glance. I haven't discussed the difference from logs and trace because it's obvious. Again, they are event-based and not fitting to give a big picture of performance of the application. Especially like other observability pillars, it is often the case where the bottleneck does not show up as a problem during the load testing, and it does in production. Sometimes those bottlenecks are critical to the service. So having the way to collect the profile of production environment is really important. So there are many profilers for each programming languages and platforms. Basic idea and usage are same among all those tools. But in this session, I use pprof for explanation because it is the most familiar tool for me. If you are a Java programmer, then you can use the flight recorder plus mission controller, of course. And also there is a more simpler tool like async profiler or visual VM. In Python, you have C profile as a standard tool, and then you can use the result of the C profile with the snake viz and the pprof. in Linux, you can use the perf as a most familiar tool for performance analytics. So the pprof. For those who know pprof via gold standard package, it sounds all-in-one tool, but in general, I mean the Google pprof is just a open source visualizer and analyzer of profile data. As long as the profile can generate data that follows profile.proto, any program can use pprof. For example, if your Python program can generate profile data in profile.proto format, then you can use pprof to visualize the results. Go ships pprof with profile data generator, so any Go users can use it out of the box. Though this session is not about how to use pprof, but how to run continuous profiling. So, I'd like to give a sneak peek of the easiness to start profiling with pprof. So I suppose developer in this conference runs servers, daemons, or whatever keep running after the launch. And what you need to run pprof is just to insert single line of code like this. So what you need to do is importing net HTTP pprof. Importing pprof package creates the HTTP endpoint automatically. Each endpoint returns each type of profiles. For instance, /profile returns CPU profile, /heap for heap profile, and so on. And by accessing the endpoint, you can fetch the profile data. After obtaining the profile data, finally you can run pprof. By default, pprof is CLI interactive tool. So without any options, it launches interactive shell to operate and analyze against profile data. By providing HTTP option, it launches web UI that gives you more intuitive and powerful analyzer. Given you have launched the pprof web UI, you'll find 6 views. I want to drill down into all menus, but I only have 25 minutes in this session, so I just introduce how graph looks like. So the graph looks like this. And the box sizes and colors are subject to the resource consumption. So in the context of debugging, in short, the larger, the worse. So it's really easy to understand. And also the edge from box X to box Y means X is calling Y. So for example, the box labeled with JSON decoder decode is calling a JSON decode state unmarshal on the left bottom side and a JSON decoder with value on the right bottom side. So on looking at this picture, it seems like JSON decoder with value is consuming a lot of resources. So maybe the bottleneck is around that function. So recently, the flame graph is more familiar in the context of profiler. The flame graph is similar to what graph explains. It shows call stacks in concise way and how the call stacks gives impact to the program's performance. The resource consumption is expressed as the length of bar. So like the graph, the longer, the worse. So in this case, main.find all lines.func1 may be the problem. Okay. So far, I have introduced what profiler does, how to analyze a program with profiler. So now we can solve the performance issue with pprof or profiler. But performance tuning is not a one-off activity. We develop and introduce new features every day or even every hour. And performance bottleneck changes every time we introduce new features or new implementations. So in metrics, we observe the changes in time series chart, and it is easy to track the changes. But profile is basically shows the snapshot of single sampling. How can we track the diffs of each profiler sampling? So continuous pprof is the key to achieve it. The continuous pprof is not a new concept. Google has been doing internally for a long time. We are taking periodical profile data and visualizing its historical trend in the stack trace. Some APM vendors are providing services that enables continuous profiling easily. For instance, GCP provides Google Cloud Profiler for it. It is the external version of Google's continuous pprof. But this conference is open source focused event. So I'll share how to achieve similar functionality with open source pprof. So this is the image of how we do continuous pprof. The bottom is the simplified image of the application with call stack. So along the timeline, the call stack changes because of the newer version release. For example, function B1 becomes B2 in version 2.0. Function C1 becomes C2 and C3 in version 1.1 and 2.1 respectively. The upper side is the metrics chart of across the volume, metrics chart of access volume or whatever that relevant to the performance. And then the middle is the average latency by distributed traces. And the orange arrow is the sampling of the profiling. What we do in continuous pprof is to take profiling continuously, literally, and then use it as supplementary clue to resolve the performance problem. One thing I'd like to touch here is that this is the observability, not just about having metrics, trace, logs, and profile alone, but to make them available to put together to solve the problems. So when we start continuous pprof, first thing we need to do is to have the correct matching between profile data and software version. The more levels you have, the more you can reinforce other observability components. In Go, we can embed value into variables with LD flags option. So this is an example to embed version number and then git revision into Go binary. Given those version and revision information, by providing the handler that returns software version and revision, we can link profile data and its file name. So once you get the profile data of different version or revision or timestamp, then now you are able to compare the diff between two profile data. In pprof, a base option sets the older version profile as the baseline for the target version profile. It only works on graph mode, but it gives us sufficient information to analyze the improvement and degradation. Different from the normal mode of graph, the comparison mode gives the diffs of values in each calls compared to the base profile in intuitive way. In normal mode, the larger and the more red boxes are the bottleneck of the performance. In the comparison mode, the larger and more green boxes are the improvements, and the larger and the more red ones are degradations. So it's really easy to understand. So this is the basic idea of the continuous pprof. So the more you take the profiler as periodical basis, then you can compare the performance improvement or degradation in regular basis, and then you can use it as a clue or supplemental content for other observability pillars. But I have introduced the how to run continuous pprof, but running this manually or creating the pipeline by ourselves requires an elaborate set of implementation in the system. So to help it, some open source projects are trying to provide continuous profiling solutions such as pprof or pprof for Go programming. However, I haven't seen many use cases reported yet, so I look forward to the more experiments and reports coming out. Of course, trying observability as a service like Google Cloud Profiler is another option. It's all up to you or your environment. Also, I'm not familiar with how other programming language ecosystem are providing the way to compare profiles. So I appreciate if you know the status of continuous profiling in those other ecosystems like the Java or Node.js and so forth. So that's all of my talk. So thank you for joining my session. I wanted to go through more details on pprof itself and then how the profiler is useful, but 25 minutes is too short to cover all aspects of profiling. I appreciate any feedback or questions. I'll be or try to be at the #speaker-Yamaguchi Slack channel after this session until the lunch break. So feel free to drop comments there. And then also feel free to reach out to me via Twitter or other sources.